Hi, this is Troy Heber. I'm a chief technologist with Hewlett-Packard Enterprise, working in the telecommunications group. I focus on manageability and a lot of our open source projects. So this workshop today is really going to focus on the Redfish API and its interaction with PowerShell, Bash, and Python. So we're going to start off with an overview of Redfish, give you an idea of the protocol itself and some of the best practices. We're also going to focus on a demonstration of it working with an OpenBMC as well as an HPE ILO 5 BMC. We're going to talk about session-based authentication, creating and deleting, doing some get and set operations, and a reset using that Redfish API. This entire lab is being delivered through Jupyter notebooks, and it's going to be a follow-along hands-on lab where we're going to do an instructor-led walkthrough where each student has their own environment, but we're going to do it kind of step-by-step together. For this, we're going to break it up into a couple different sections. The first section, we're going to use either Bash or PowerShell to do the first lab, and then we're going to come back together with Python to do the final lab. So I'll explain more as we get into this. But for right now, the first thing to do to get started is for everyone to get into the environment. So please use this URL here, point your browsers to notebooks.hpedev.io. Every student should have a student number. You'll log in with student and then your number, and then the password is here on the screen. Everyone should have got these already assigned by email, but if you're having any issues, please use the Zoom chat window to ask any questions or to request any assistance. With that, let's switch contexts and jump into this. Okay, at this point, we should all be getting logged into the Jupyter Notebooks session. I just need to get my server reset here. And once I get logged in, okay. So hopefully at this point, everyone is looking at the same screen as that I'm showing here. This is the Jupyter Labs setup that we have. On the left-hand column is going to be all of the individual notebooks that we're going to be using for this lab assignment. So if everyone would start by clicking on the README First notebook and opening that up from the left-hand column, we'll see it opens here on the right side of the screen. And it's really going to give us a chance to kind of walk through the environment we have here and what we're doing. So today, we're really starting with that introduction to using the Redfish API. We're going to do it again using a multitude of languages to really show that it's a flexible API that can be used in any language that you prefer. We think that some of the most common languages around right now are Bash for more of the traditional Linux side, Unix side, as well as PowerShell for the Windows users, and then Python, which really covers all the dimensions. So for this lab flow, we're using, again, these Jupyter notebooks. They allow us to have dynamic content where we can actually interact with code on the fly as we walk through it step by step. You're free to take a copy of these notebooks. You can right-click on them and save them to be able to be used later. So let's jump into it. Starting off with the, why are we here and what are we talking about? Well, we're really starting with what is Redfish. So Redfish is an open standard created by the Distributed Management Task Force. It's been around now since 2015 for the introduction of the specification, so for 5 years. And really why it's becoming interesting at this point is that it's starting to get enough use in the field that we can actually start consuming it. We're really at that inflection point where the amount of servers in the field that implement this are at the tipping point where a majority do versus legacy servers that do not. So Redfish is designed to really help us implement the software-defined data center. It is an open consortium. HPE was one of the founding members of the consortium, and bringing this protocol for the next generation of system management and monitoring. It does work on a wide variety of devices, including HPE servers with our ILO 5 and previous versions with ILO 4. So the goal of this is to help understand how to interact with this API and to leverage it, the best practices of leveraging it. For this workshop, we're going to have a dedicated system for each individual student. So this picture is going to depict, the environment that we're logging into right now. On the left-hand side, we have OpenBMCs. So these are baseboard management controllers that are being emulated, and we have a dedicated one for each student in this workshop. So we'll be accessing those via code that we're running in the Jupyter notebooks. On the right side of the picture, you're going to see that we have a single HPE server, in this case, with an ILO 5. And as we move through this, we're also going to leverage that, but this is going to be a shared resource. So everyone will be accessing the same ILO 5 device. The way that this lab works is on the left-hand side here, you're going to see additional notebooks. We have notebooks 1 and 2, which are going to be lab 1. So the first one is this lab written in Bash, and the second one is the same lab written in PowerShell. They're virtually identical. So for the purpose of this, you can choose which one you want to start with as we walk through it step by step. I'm going to be walking through the PowerShell, but again, they're completely identical. Just the command implementation is different. And one of the keys that we're starting with here is that both the Bash and the PowerShell are just using standard HTTP requests to leverage this API. We're not using any additional libraries or mechanisms to abstract this out. It's base HTML for how we're communicating. After we finish walking through labs 1 and 2, or the lab 1, we're going to jump over together to look at the Python lab, and I'll talk more about that as we get into it. Finally, I want to mention that this is being a Hack Collab session and brought by the HPE Dev community. So HPE Dev is a community. It's looking for developers who are interested in participating with things like Redfish on HPE servers. So feel free to check out this QR code and join into the community. Okay, with that being said, let's jump in and open up our next notebooks. I'm going to open both the Bash and the PowerShell just to kind of show that these are identical as you walk through them. So we are using Jupyter here to execute code against our OpenBMC simulators. The way Jupyter notebooks work is that each section is called a cell, and some cells can actually be executed. So the one you see here in the lighter gray box is the first cell in this notebook. In this cell, this is actual PowerShell code that we're going to be executing. So at the top, we're just setting up some variables. I have my student number, which is unique to each student. Yours should be different than mine. So in my case, I'm student 117. Next, we're going to set the BMC's IP address using a host name, in this case, OpenBMCS, and then a unique port for each student, because we have each simulator running on a different port. Finally, we're going to combine all of those together to have a complete URI for our first Redfish resource. Next, I've added some code here that's unique to the PowerShell, just because I wanted to make sure that this lab shows all of the possibilities. We're going to talk about authentication in Redfish and session management a bit later. But this is the code that can be used to do basic HTTP auth using PowerShell. I left it in here as a note so that you can see how it works in case you did want to use HTTP basic auth. We don't need to do that on the bash side because curl, the command that we're using on bash to do the HTTP calls, implements it directly via arguments. So I do want to show, by switching over to the bash section, that we're really doing everything identical on the PowerShell side as well as the bash. So again, here we're setting those same variables that we were setting there, setting the same basic auth, but we're not actually going to be using basic auth for this lab, and we'll talk about that as we get into the authentication section. So I'm going to jump back over to the PowerShell, and we are going to start by executing the code in this cell. The way we execute it is by clicking into the cell and then hitting the play button at the top of the screen here, the triangle. While the cell is executing, we'll see that there's an asterisk up here on the top left corner. So when you do see an asterisk, you know that that is actually executing. Once it's finished executing, we'll get a number showing the job that's actually ran. And then below the cell is where we see the output of this command. So here in this case, we can see that this code was supposed to echo out our student number. So by running it, I can now see that I'm student 117, and we're able to continue on. Now, another thing that's really important about understanding Jupyter Notebooks is that each cell actually builds upon the previous cells. So by defining our environment variables up front here, we're able to leverage those in the cells below us. So we're moving on, and we're going to get into the next cell here. The first thing to understand about Redfish is that every single device that implements the Redfish interface must have a service entry point at a known URL. And that known URL is the one that we built up at the top here, being the IP of the system /Redfish. So what we're doing here is we're going to use, in this case, PowerShell's invoke web request to do a HTTP GET against that URI, that URL that we provided. So when I run this, we're going to see that we did our GET. From the response from that, we're printing out here is our output. I can see that in this case, we do have a Redfish endpoint, and it is implementing V1 of the Redfish protocol. Now, I'll also mention that this is version 1 of the protocol, but don't get confused about the versioning. Redfish separates the protocol away from the versioning of the schemas that it provides. So right now, there's only a single version of Redfish, and that is V1. So knowing that we do have a Redfish device, we can now get to what's called the root service. And this is a really key point for how to access the Redfish API. The root service is going to be at a known URI in this case, since it's V1. We queried the Redfish. From there, we built up to the versioning. In this case, we can see our URI is now using that version information we got, version 1. And we're going to do the same thing, doing a GET against that versioning. And from here, the response we get is, again, called the Redfish service root. This lists all of the different services that this particular Redfish implementation is providing. And it's really important to understand that the Redfish API is designed for users to start at this service root to discover how to interact with it. So, for example, if we look here, we can start with seeing that the ID, again, is the URI of our resource. This is our object. In this case, it is the service root. We can see that from the OData type. We can also see that this service root is version 1.5.0 of the schema. So this is kind of the multi-versioning in Redfish, that the data that we're actually working with has its own version independent of the protocol that we're using to access it. From here, we can see some really key things that this particular implementation is providing several services to us. So it's providing an account service, and it's providing it at a dedicated URI here. We can use the OData ID to see where that service is implemented. Certificate service, chassis ID, JSON schemas. So this is another way, again, that we can query using Redfish to understand the data model that it's providing. And then when we look at the other pieces outside of the services, we see that we're implementing things like chassis, session, and managers. And these are actually the keys of managing the underlying physical infrastructure that this data model is representing. So the Redfish service route, we noticed that we were able to directly access by just doing a simple HTTP request with a GET request. It doesn't require any authentication. This is part of the discovery of the Redfish protocol. Well, to do anything under the service route, using any of these things we can see that it implements, it does require that we are authenticated with it. Now, Redfish supports two types of authentication. One is the HTTP basic authentication that I mentioned at the top. This is the simple authentication where you're providing a username and a password with every call into Redfish. The problem with basic auth is that the devices that we're generally talking to via Redfish, so the BMC devices themselves, tend to be small embedded devices. And each individual request takes a lot of resources on that device. So if we're bombarding it with a lot of requests and we're using HTTP basic auth, we can basically have a denial of service attack against these small embedded devices. So the alternative to that is to use the session service if it's implemented by the device you're talking to. And session service is basically just like logging in to a resource. It allows us to use our credentials to create a session, and then we can use special tokens for any further calls while that session is still open. So that's exactly what we're going to do here next. If we jump into our cell, we can see that we're going to create a payload of our username and our password. So this is going to be JSON that we're going to be sending to the Redfish session service, which we can see here is our URI. Now, we got this information of what to contact by looking at our service route. We saw that the session service is implemented, and it's implemented at this specific location. Jumping down, we're going to use that same invoke web request, but this time we're going to do a post method, and we're going to give it the body, that JSON credential information we have. And what we hope to get back from a successful login is a token, which is unique to this session, and the location in the session service of our actual session. So when I run this, we should indeed see that we were able to successfully log in and get that information. So this token here is now our token for future authentication in this session. And then the location is a unique URI to this session. So anyone using this token now basically has our credentials for the life of this session. Now that we've been authenticated, we can actually dive in and start to look at some of the more interesting features that we can examine from Redfish. So let's start by taking a look at the BMC itself. So we know that at Redfish V1 managers, again from our service route, is where we can find out information about the BMC itself. So if we jump down using our new authentication token in our header, so we're setting a token with the variable we got above, we can do a get on Redfish V1/managers. When I execute that, I'm able to see that we do have a BMC on this Redfish implementation, and it's a collection of resources. In this case, we're talking to our OpenBMC, and the collection contains a single BMC, which is pretty typical for a single server. Most individual platforms like a server have one BMC. However, there are many platforms that exist where you could actually have multiple BMCs. Things like chassis-based solutions, such as HPE's Moonshot, has a chassis manager that does provide Redfish interface, and then all of the individual ILO BMCs underneath that would show up here as a collection of BMCs. This shows that Redfish itself, the data model, is very flexible in representing multiple different types of hardware. Now that we know where our individual BMC is, and it's at this location, Redfish V1 BMC, we can query that. But I will stop to mention here, again, from the Redfish perspective, we really needed to start at that service root and then read the information of where our managers were to get the URI to then find out that this particular BMC is implemented at this URI. If we were to query our ILO instead of the OpenBMC, we would actually find that these URIs, these URLs are different. And a common mistake amongst people starting to use Redfish for the first time is to start to hard code these URIs and assume that they're always going to be at that location. And that is a fundamental mistake. Redfish is really designed that you need to start at that service root and query where the individual objects actually reside. So using this information, let's take a look at the BMC that we have in our simulator. So here we've got code that's actually gonna walk through the return from the previous response. And this code's actually showing that we know that there might be more than one BMC implemented on the system. As I talked about Moonshot having multiple BMCs. Additionally, things like our ILO amplifier product can aggregate BMCs together and provide a northbound Redfish API. So this code is going to not assume that we only have a single BMC. It's going to walk through each of the members and query them individually. Again, in this case, we do only have one, so the output is going to be from that single one. But this is where we can actually start now to see some useful information about the system that we're managing or monitoring here. As we dive into it, the first thing we can see is, again, the OData ID, which shows the URI and the object that we're accessing. We can see that it's implementing version 1.30 of the schema. And the first thing under here is actions. So these are a list of actions that we're actually allowed to perform on this object. So you'll notice that our BMC implements a reset action, and it allows a graceful restart of the BMC itself. So this is actually something we're going to be using a bit later. But notice the target here, all the information we need to understand what we can do to this BMC is being provided by Redfish directly in the responses of querying it. We can see lots of other information being listed here, such as the Ethernet interfaces for the BMC, firmware versions, the number of connections that are supported for a graphical console. More interestingly, the manager for chassis. So this allows us to, if we only know the BMC, we can figure out which system or chassis it's managing. So if it's an individual system, it would be one. If it's something like the Moonshot, it would be the chassis as a whole. But from here, we can dive into that resource. We see other things for the particular system itself, login services, and then we get to something that's unique, and that's the OEM section. So Redfish itself tries to standardize the schemas. So the things above you see, such as manager type model, these have been implemented in the Redfish schema, the manager schema version 1.3.0. So anything implementing that must provide those endpoints. However, Redfish didn't want to restrict to having to have things standardized before they could be used. So it has this concept of OEM, where it allows manufacturers to implement things that are unique to their implementation prior to them becoming standardized by the Redfish organization. So in this case, we can see that our OpenBMC has a certificate store that's unique in the OEM tree. Finally, we can see information about the server itself here, that the system is running and that the health status is okay. So being able to do a basic query like this, we can monitor the system itself just by reading these values. Okay, so jumping down, we actually might want to take a look at modifying something. So in this case, the value that we really want to take a look at is going to be under our network protocols. So let's start by taking a look at what protocols this particular BMC implements. We know the URI of the network protocols from being above. And so we're just going to do a get on this URI. And see which protocols this BMC implements. So here again, we see our ID of the resource, the type and the specification. And now we can see the list of protocols. In this case, we can clearly see that HTTP is not supported, but HTTPS is. Moving down, we can see that it can use NTP for getting time from external NTP servers. And in this case, we don't have an NTP server set, and we can tell there's an empty value here. So NTP is extremely important for BMCs, being able to have time synchronized for common logs. So let's go ahead and change this by adding an NTP server. Well, the way we can do that, if we jump down to our code here, we know our URI of where this resource is, and we can see that we had the ability to set an NTP server here. So I'm going to build up a body of JSON that has NTP with an NTP server value being set here. And this time, rather than doing a get, we're going to use a patch operation to just change this particular resource or this particular value in the overall resource. So when I execute this, we notice, first of all, that we didn't get any output. The reason is that we're doing a patch, and the HTTP response is a 204, which means that it succeeded. So the next thing is, well, we know that the action succeeded. How can we make sure that it succeeded? Well, we can do that by simply doing a get on the network protocol section like we did above, and just make sure that that change has been implemented. So I'm going to go ahead and run that, and we're going to query it, and we're just going to specifically look at that NTP server value from our BMC. And indeed, in this case, we can now see that it has been set. So by using that patch, we were able to make a change directly on the BMC, and that change is actually one that was instantaneous. So this BMC is now able and starting to query time from the NTP server. Now, not all changes that you make in a BMC are instantaneous. Some of them require an actual restart of the BMC itself. So let's take a look at that by jumping in and resetting this BMC. Similar to above, we're going to build up a body with the change we're going to make. Now, if you remember from the beginning, we did notice that this BMC supported that reset action. So we're using that information and the URI we got from there to perform this. We've got our body set to graceful restart, again, which we were able to see from our initial query. And at this point, I'm going to print out the date of when we performed this reset action. So I'm running it here. We can see that the date and time that the reset started, and I can see that in my message ID that this operation was a success. Now, one thing to notice here is that we're actually doing a post in this case to implement that action. So previously we used a patch to make a change to an existing value. In this case, we're using the post to perform the action on that reset object. Now, since we are actually using real BMC simulators here, that BMC is doing a restart in the background. And that restart does take some time. So in order to watch for it to come back up, we have a bit of code here that's going to loop and just keep checking until we get a response from our BMC itself. So when I execute this, we should see that we've got that asterisk showing us that this code is indeed running, and it's just going to keep looping until the BMC comes back online. Okay, at this point, we can see that our BMC is back online from its reset, that our code did complete, and we finished that operation. So the last thing that we need to do is to basically log out of the session that we established. Again, we're talking to embedded resources here that have a limited amount of sessions they can support. So it's really crucial to make sure that we log out by deleting our session when we're finished querying the BMC. So in this case, as I mentioned, it's going to happen via a HTTP delete operation. So back when we did our session service and our login, we got two values. One was our token, which is used as our credential, and second was the location of our session itself. We're going to use that location information as the endpoint for the delete operation. So when I execute this code here, we can see that it was successful and that session has now been terminated. Okay, so that completes lab 1 for both the Bash and the PowerShell side. Now, the really key things to take away from this lab is that we actually covered all of the major operations for the Redfish API. And we did it all using standard HTTP requests. We started by accessing the service root at a known URI for Redfish. And from there, we were able to slowly build up from that service root, find out which endpoints that this Redfish implementation implements, and then to access those. We did gets to do reading, which can be used for monitoring the individual hardware. Information such as the health status was easily available via get operations. We did a patch to modify the settings of the BMC itself and have those take advantage immediately. So we patched in an NTP server. And then finally, we did the post to reset using one of the Redfish actions, and then we logged out of our session. So each one of those primitives can be used for basically any Redfish operation that you'd want to do. So hopefully that's clear, and you can use this to build up and access Redfish API in general. Now with that being said, let's move over and take a look at PowerShell. Or I'm sorry, Python. We just finished PowerShell. So this PowerShell or Python lab is going to be slightly different in that we're not just going to use raw HTTP primitives to access the Redfish API. Instead, we're going to start by leveraging a library that the DMTF publishes for Python. So we can access that library on the DMTF's GitHub using the URL that's located here. But the library itself makes it easier to do some of those HTTP primitive things in Python. So it takes that away from, it abstracts it away from the actual developer, letting you focus on the Redfish implementation directly. So just like we started off with the Bash and PowerShell, we're going to do the exact same thing in the Python example here. We're going to set up our environment just like we did there. The difference being that we're going to start to use some of the libraries from Python. So we're importing the things that we're going to use, such as the OS service, the regular expression, JSON, and again, that Redfish library that I was just talking about. Where things are the same, I'm still student 117, and we still have our basic credentials here. What's different in this case, and what we're really going to try to show, is that we're going to access both our BMC that's being emulated, our OpenBMC, as well as our ILO 5. And the thing to really pay attention to as we're going through this is we're going to use the exact same code to access both of these different environments. And we're going to see that the environments themselves are going to respond differently. I mean, they're responding via the protocol, but the schemas are, the URIs and such are actually different between the versions. So let's jump down. I need to execute my first cell to get this set up. So let's make sure that runs. Indeed it did, and I am student 117, and we have our variable set. One thing I'm going to mention here that is slightly different in this notebook versus the previous ones is that we're not building every single cell on top of each other. Some of these cells are going to act independently from the others since we're accessing different environments. So here we're pulling in our BMC IP address, and we're starting by creating a Redfish object. So in this case, we're doing the Redfish library to get that Redfish session object. To instantiate that object, we're using the URL and our credentials. So when this sets up and that's instantiated, it's going to go ahead and log in using the session service, and it's going to get us that same session key and location that we saw in the previous examples. It's also going to get us access to our service root. So this is exactly the same thing that we did in the first cells in the previous lab, but now we're using the Python library to both authenticate and get that root service. So let's go ahead and run it. And indeed, we can see that we are accessing the root service. We still see that it's implementing version 1.50 of the protocol. And we can see exactly the same thing we saw before of all of the different Redfish interfaces that this implementation is implementing. So from that starting point, again, starting with that session service, we can build up and we can move down and take a look at managers, just like we did in the previous example. So we're going to start with our OpenBMC IP address. And this is where I mentioned that we're instantiating that new session with every single cell. We're not building on a single session and logging in. So it's because of the way that this Redfish library works in Python. So we've got to do that again, establish a new session. Once that session's established, we're going to do the HTTP GET, and we're going to start at the service root. And then from that service root, we're going to read that manager's object and the URL inside of that manager's object to get that endpoint. So again, the key point here is that we have to start at that service root and we have to query where the manager's object lives. And once we have that information, then we can query it. So we're building up, just like we did before, getting this information. And once we know where it lives, then we can actually access it directly. So here, we're going to switch from doing that query on the OpenBMC to doing it on the ILO. So again, this is the exact same code that we saw above. If you look, there's no difference in the code other than we're changing our IP address variable to be the ILO5 now. When we execute this, we can actually see the output is a bit different. So this is a different service. And we can see, if we compare the output of both of them, that the actual location of the resource we're looking at, the manager itself, is very different. So the member section of the OpenBMC up here shows us that the BMC lives at the URI of Redfish v1 managers BMC. But in the case of ILO5, the manager's OData ID tells us that it lives at Redfish v1 managers/1. So it's the same code, but if you start to make that mistake of hard coding the URIs, you're going to see that it's not portable between implementations. So the real key here is to understand that you start at the service root. From the service root, we know that we can use the manager's OData ID to get the location of where the actual BMC is. So now that we have that information, we can dive in and actually start to query it to get a little bit more useful details out of it. So switching back, we're at our OpenBMC now. I'm going to execute this code, which is going to start at the service root, again, get that manager location, and then do a query of each of the BMCs. So this is the same code that we kind of executed in the PowerShell and the Python, or I'm sorry, the PowerShell and the Bash. We're now doing it in Python. So this is exactly the same thing we saw before. This shows us, again, the actions that it implements and all of that common information. Also, one of the things that we queried in this to highlight and show some of the differences is the Ethernet interface collection specifically. So we were able to start at the service root, go to the managers. From the managers, we went to the Ethernet interfaces and then queried the Ethernet interface collection at that URI. And we can see now that it's a collection of two interfaces on our OpenBMC. Interface ETH0 and SET0. If we do the exact same code on ILO5, so starting at the root, going to get the members for the BMC, and then from there to query the Ethernet interfaces, we can see that the ILO implements the reset action just like the OpenBMC manager did. We can see our Ethernet interfaces URI. We can start to see a lot of differences in the services that ILO implements, especially things under the OEM tree. So this real hardware implements things that are unique to ILO outside of the OpenBMC itself, or I'm sorry, outside of the Redfish standard schema. And you can see quite a bit of information that's unique to ILO here. And then the common things again, like serial number and status. But if we look at our Ethernet interfaces, we can see that ILO, in this particular case, has 3 Ethernet interfaces. So this is, again, very different from the OpenBMC, but we're using the exact same Python code to access this information. And so even though the data itself is different because we have different hardware and different implementations, the code itself is common. So diving in just a little deeper, we can query, now that we have our Ethernet interfaces that are being provided by this BMC, we can take a look at something unique like the MAC addresses. So we're taking that exact same code that we started with above, and we're just building on it. So again, we start with our OpenBMC IP, we create our Redfish object using our credentials, so that establishes the service. We start at the service root. From the service root, we get our BMC data from our members. From the BMC data, we get the Ethernet interfaces. From the Ethernet interfaces, we get the collections of the actual interfaces themselves. And then from those, we can get information such as the MAC address. So when I run this against the OpenBMC, we can see that we're querying each of the individual interfaces that we saw earlier and pulling out the MAC address for each of those interfaces. If I come down and run the exact same code on the ILO, I can see that I'm getting a MAC address for each of the 3 interfaces. So hopefully this was a good tutorial of showing how that no matter which language we're using, whether we're doing raw HTTP calls in PowerShell or Bash, or if we're using the Redfish provided library for PowerShell, the way that we're accessing the Redfish API is the same across all of them. And the real keys is to understanding that we're starting at that service root, and we're using the information that's provided by that query to build up and access more detailed information. So starting from the root and then moving all the way down to get something like the MAC address from the Ethernet interfaces that are implemented in the BMC. So before we close, I'm gonna switch back over to wrap things up. So I really appreciate everyone that's taken their time to go through this session with us. We certainly hope this has been valuable for you. And we would really appreciate if you would take a minute to fill out the survey at the end of this workshop. So if you've noticed, I'm showing a PowerPoint slide and you can't click on this link, but that same survey link is in the Jupyter notebook, the conclusion of the Jupyter notebook that you have in your lab environment. So please click on that and fill it out. So thanks for your time, and we hope you found it useful.